Hi everyone, welcome to all of you in my lecture today. So today I'm going to discuss about the plant design economics. So this is just a revision class that I'll be talking about most important topics of the plant design economics. So here you can see I have started from the depreciation in the previous lecture where I have talked about the value of instrument or assets decreases with time, and the decrement in the value of assets is called as the depreciation. So depreciation may be, I mean, there may be several reasons associated with the depreciation, but I have categorized three main important reasons that can, constitute the depreciation. So first one is your physical depreciation, second one is depreciation due to the technological advancement, and third one is the economic sense. So when we talk about the physical depreciation, so let's say physical depreciations associated with the change in the or the decrement in the value of assets due to the damage or physical damage, right? So for example, let's say if you have bought your mobile phone initially, and once let's say your mobile phone's screen got damaged, and then you want to resell. So I mean, you want to resell this phone, so the resale value will be, you know in the market, will be less compared to the you know initially the cost at which you have bought the phone, due to the reason of decrement in this value is due to the damage of the screen. Second one is the technological advancement. So if I'm talking about technological advancement, so let's say whenever the new iPhone comes into the market, the value of or the cost of old iPhones get decreased, right? So this is the reason. I mean, because the new iPhone, their latest one, is more technological advanced, that's why the cost of that one is more. So sometimes depreciation happens due to the economic changes also. So there are mainly this kind of things mainly affected by the intergovernmental ties between the different countries. Let's say the value of rupees or INR get decreased on the international or global level. So in that condition, definitely the value of your assets will decrease. So this is some reason associated with the depreciation that I have told you. But the most important thing that is important for the data examination is the methods that from through which we will be able to calculate the depreciation. So here I will be talking about two methods through which we will be calculating the depreciation. First one method which consider the time value of money, and method which does not consider the time value of money. So first I will be talking about the method that does not consider the time value of money. So here in this particular method, you will see there are four different methods which is available for the depreciation calculation. First one is straight line method, decline balance method, and double decline balance method, and sum of year digital method. So I'll start with the straight line method. So here in straight line method, the assumption says that the depreciation in each and every year will be same. What does it mean? So let's say depreciation in first year is B1. So in depreciation, second year is B2, depreciation is third year is B3 and BN. So that is equals to B. So here you will see the depreciation in all these years are same. That's why this is the simple or basic assumptions of your straight line method for the depreciation calculation. So if you will start calculating the depreciation while assuming the initial cost of the equipment is V0 and the salvage value or service, scrap value after the n year is your VS, then depreciation can be calculated as G equals to your V0 minus VS divided by n. This one is your depreciation, where V1, that is the assets value after 1 year of the depreciation, can be written as V0 minus D, and V2 can be written as V1 minus D, and through which so and so forth you can calculate the book value of the equipment after AH year, that is VA, that is equals to V0 minus A multiplied with D, where V0 is your initial cost of the assets, VA is the book value of the equipment after AH year, and D is the depreciation. So here you can see, if I'll plot the cost of equipment versus time curve here, so here you will see it will start from V0, right? And after that, what you will see, there is a slope and intercept. So intercept is V naught, so this one is V naught, and the slope is a negative slope, and this slope will give you the value of D. So let's say if this plot has been plotted between V naught and A, so you will see that the slope of the slope of this V versus A curve will give you the depreciation amount by straight line method, and the intercept will give you the initial cost of the assets. So this is how the straight line method works, and you can calculate the depreciation. Now, next method that comes here is the decline balance method. But in decline balance method, the assumption is different. Here, the assumption is not that the depreciation in each and every year will be same, but the percentage fixed factor will be same. What is percentage fixed factor? That let's try to understand that percentage fixed factor can be calculated as 1 minus Vs divided by V naught whole to the power 1 by N, where Vs is your salvage value, V naught is the initial cost of the equipment, and N is the service life. So here you can calculate that. If you want to calculate depreciation, so depreciation can be calculated as, let's say, V1 equals to V naught multiplied with F. While we calculating G1 equals to V naught multiplied with F, we have calculated the value of F, that is 1 minus Vs by V naught, and depreciation in first year can be written as V naught into F. Again, if you want to calculate D2, so D2 can be written as V1 multiplied with F. Again, V1 can be written as V naught minus D1, V naught into V naught multiplied with F. So you will be getting V naught into 1 minus F here. So similarly, if you will substitute all these values, so finally you will be getting the book value of equipment after AF year, that is equal to V naught into 1 minus F whole to the power A. So this is very important formula that you have to understand and you have to remember while calculating the depreciation by decline balance method, right? But here you will see that that depreciation, we have assumed that depreciation in every year is not going to same that we have assumed in straight line method. Here, if you will see, the curve will look like that. So initially, you will see there is a very steep curve, right? And after that, you will see the curve will get the slope of curve is decreasing. So if you want, if you'll see that decline balance method will give you more depreciation of more depreciation in the early phases of the service life compared to the later periods. So, I mean, if someone, I mean, if the question is there that which method will give you more depreciation in early phase of the equipment, so you'll have to, mark the question, that is decline balance method, because the slope here is more compared to the straight line method. That's why the decline balance method will give you the more depreciation amount compared to the straight line method. So this was the two methods that I have discussed in previous classes. Now I'll be talking about the double decline balance method, and let's try to understand third method for the depreciation calculation by. So it will be written as GDBL, right? But if you think about in decline balance method, the percentage fixed factor, it was equals to 1 minus Vs by V naught whole to the power 1 by N, right? This was your percentage fixed factor in case of decline balance method. But let's say if your Vs is 0, the percentage fixed factor will become equals to 1. So in order to overcome this problem, we'll go for the double decline balance method. So what double decline balance method says that the percentage fixed factor can be written as 2 into V naught minus Vs upon N into V naught, right? So this one is the percentage fixed factor that will be used in double decline balance method for the depreciation calculation. And rest of the calculation will be same. If I want to calculate, let's say V1, so V1 is, sorry, depreciation in first year, I'll start from the V note is the V note is the cost of original cost of the equipment, and V is the salvage value having service life is N year. So here, let's say this one is your V1, V2, V3, and so forth. So your depreciation is V1, V2, V3, and so forth. So if I want to calculate the depreciable amount in first year, so how we can calculate? While we writing depreciable amount D1 equals to your V1, V naught multiplied with F. And after that, you can calculate the assets value V1 equals to V naught minus D1. So you can also write V naught minus V naught F, that is equals to V naught into 1 minus F. Similar process that we applied here also in case that we have used in decline balance method, but only percentage fixed factor formula is different. So let's say if I want to calculate D2 is equals to V1 multiplied with F, and V1 is equals to V naught into 1 minus f into f, right? So if I want to calculate V2, so V2 equals to V1 minus V2. V1 calculated as V naught into 1 minus f, right? Minus V naught into 1 minus f into f. So if you will calculate V naught into 1 minus f common, so you will be getting this thing. So that is V naught into 1 minus f whole square. So similarly, if you will do the calculation for AX here, so you will be getting V naught into 1 minus f to the power a. That is the VA is the book value of the equipment, and F is your percentage fixed factor that we have defined V naught minus VS divided by N V naught. N is your service life of equipment. So I'll be going a bit fast because this is a revision class, so I won't be spending so much time for a particular topic. But yes, I'll try to cover most of the thing over here. So this is how the double decline balance method works. So if I mean, how can you understand that whether we have to use decline balance method or double decline balance method? So if salvage value has not been given in the question, right? So if salvage value is 0, then you have to use your double decline balance method. So how to use when Vs has been given to 0. So if Vs is 0, if Vs is 0, then your percentage fixed factor, that is 2 into V naught minus Vs divided by N V naught. So it is 0. So it will becomes 2 V naught by N V naught. So that is equals to 2 by N. So the percentage fixed factor that will becomes like that, and you will be calculating that is 2 by N. And after that, you can use the same formula that I told you earlier, and you can calculate the book value of assets. So till now we have studied about double decline balance method. So I was talking about that double decline balance method can be used when there is a scrap value and salvage value is given. In both the condition, we can get the double decline balance method I mean depreciation by double decline balance method. And next thing is that double decline balance method. I mean the plot of double decline balance method and decline balance method will look like same. So if it is V and if this is V, so it will start like that, and again it will follow the same similar kind of curve. It will start from V naught, and for first year the depreciation amount will be highest, and after that the depreciation amount will get decreased. So if this one is n equals to 1, n equals to 2, n equals to 3, so here you will see that is V1, V2, V3. So initially you will see the slope is highest in the initial phase, and after that the slope will get decreased. So this will follow the similar trend like your decline balance method. So this is your DDBM method, right? Now, the fourth method that I'm going to talk about is the sum of year digital method. So I'll be talking it as SDM, right? So in sum of year digital method, again, the depreciation amount is not the same in every year. So the assumptions here also, assumptions based question can be asked. So D1 is not equals to D2, which is not equals to D3, and so on and so forth. So here also, first assumption, second assumption is that percentage factor is not same that used to in your decline balance method or double decline balance method. So the formula for the depreciation here is given as 2 into n minus a plus 1 into v naught minus vs divided by n into n plus 1. So this formula for depreciation you can use that where this one is a and 1, where v naught is the original cost, salvage value, a is the kth year in which you want to calculate the depreciation, and n is your service life of assets. So this is how this particular method works, and you can calculate the depreciation. Once you have calculated depreciation in year here, you can calculate the, let's say this one is your V0, so this one is your V2, V3, V4, and let's say Vs. And so let's say this one is your first year, so you can calculate substitute A equals to 1, you can calculate depreciation in first year, that is equals to 2 into n minus 1 plus 1 into obviously V naught minus Vs divided by n into n plus 1. So n will be given to you, and based on that, you have calculated D1. And once you have calculated D1, so you will be able to calculate the value of V1 equals to V naught minus D1. Again, you can calculate V2 equals to V1 minus D2, that is equals to V naught minus D1 and minus uh, D2. And again, if you want to calculate V3, so V3 is equals to V2 minus D3, and V2 you have calculated V naught minus D1 minus D2, and obviously it will be minus D3, right? So VA can be calculated as V naught minus summation of DI equals to 1 is to A. So this is the formula that you can use. And obviously formula for DA, I have told you that 2 into V naught minus Vs into n minus A plus 1 divided by n into n plus 1. So this formula, these two formula is very important while calculating the depreciation and book value of assets while using the sum of year digital method, right? Now, till now we have studied about the depreciation calculation and all the cost, relating to the particular assets. Now I'll be talking about the cash flow calculation. It's very important. And so these topics are very favorite to the GATE examiners. So that's why you'll see the questions in every year from the cash flow calculation also. So if we are having the, if we know, wait 1 second. So let's say if in arithmetic, if you want to define the profit is your selling price minus cost price, right? So this one is your CP. So this is how a profit can be defined in case of arithmetic. But here, in case of plant design economics, we want to define these things in the more technical way. So if I want to define profit, so it will be called as the profit before tax. Profit before tax, that is called as the income minus expenditure, or sometimes it is also called as your income can be also written as a total annual revenue, and expenditure can be also written as total annual expenses, right? So this is how this technical terms can be used in case of plant design economics, right? So if I'm talking about profit before tax, right? So profit before tax, now you can write total annual revenue minus total annual expenditure, right? So this is your profit before tax that you have calculated now. But what happens in case of plant design economics, if you want to start a plant, so you'll have to give the tax to the government, right? So but you want less tax, I mean, to be given to the government because you want to save some amount of money in the starting period of plant operation. So in the starting period of plant operation, you want to save more and more amount of tax, or you want to get rid of the more amount of less amount of tax that should be given to the government, right? So what happens? You will be calculating the taxable profit that is equals to profit before tax minus depreciation. So depreciation will be also based on annually. So you will calculate depreciation. Already I have discussed the method of calculation of depreciation. And let's say phi is your tax rate. If phi is your tax rate, then you can calculate the tax paid to the government. That is your tax paid. That is equals to taxable profit multiplied with phi. Right. So once you have paid the tax, then you want to calculate the profit after tax. That is equals to profit after tax. That is equals to obviously PBT into 1 minus 5. Or before you want to write PBT into 1 minus 5, you can calculate these things. That is what is your taxable profit? So taxable profit is PBT minus depreciation, and you want to decrease this value taxable profit minus tax paid. So finally, you will be getting the profit after tax. So you can write taxable profit minus tax paid. So you can calculate tax paid, that is equals to PBT minus depreciation minus PBT minus depreciation multiplied with 5. So finally, you will be getting profit after tax, that is equals to PBT minus depreciation into 1 minus 5. So this one is your profit after tax. It's a very, very important formula. Now, once you have calculated the tax profit after tax, you will calculate cash flow, which is called as a cash flow. Cash flow equals to profit after tax plus again depreciation. So you'll be calculating this particular value based on that. So this is how a cash flow can be calculated. And I will not be discussing any questions here right now, but I'll be talking only about the concept. And after that, I'll move forward towards the depreciation benefits. Also very important. Later ask questions on this particular concept once, that is the depreciation benefit. So let's say you are calculating depreciation by two methods. I told you calculation. If you are trying to calculate by a straight line method, decline balance method, double decline balance method, or some of the digital method. So if let's say you want to compare that, in which method we will be able to save more amount of tax. That means that will be called as the depreciation benefit, right? So the depreciation benefit can be calculated as that is equals to depreciation by method first minus depreciation by method two. Fine. And you will be multiplying with your 5. That is your tax rate, right? So that is called as the depreciation benefit, right? So let's say while comparing the depreciation decline balance method over a straight line, method, the depreciation benefit for the initial years comes out to be positive. That indicates that more saving is there, right? So during the year, a plant needs more money to continue its operation in order to get it set in the market. So in this period, what happens? Use of decline balance method is very advantageous as compared to the you know advantages, as the depreciation amount in decline balance method (DLC) is higher in the initial year, which allow less tax paid to or more cash inflow, right? So obviously, I have told you that depreciation is tools that can be used to save the tax. And this saving of tax is very, very important in the initial period of starting of the plant. So, according to the concept of depreciation benefits, so you can say that decline balance method is the best method for the depreciation and preferred over the another method also. So these things you need to remember that decline balance method is the most advantageous method for the depreciation, right? So till now we have a study about all these concepts of depreciation and cash flow. Now I'll be talking about the interest. So in interest, I'll be talking about two kind of interest, and you must be knowing these things. That one is your simple interest, and second one is your compound interest. First, I'll be talking about the simple interest concept, right? So generally, what happens in simple interest? Let's say let your principal is B, right? And then let's say your interest rate equals to I. So if I want to calculate the simple interest is equals to P into I multiplied with M divided by 100. This one is your simple interest. So for any particular amount, if you want to calculate the total amount after n year, that is equals to principal plus simple interest. That is principal plus P into I into n divided by 100. So if we will take common P, so it is equals to 1 plus IN divided by 100. This is the amount that you will be getting for the interest rate I after nth year, right? So this is how you can calculate the simple interest. So I mean here in simple interest, what happens? You will be getting interest only on the principal amount, not the interest. But let's say how simple interest differs from the compound interest. I'll show you later on. So let's say the compound interest. So you will be getting interest on interest. How it works? Let's try to understand. So let's say this one is B. So if for first year, if interest rate is I, so here you will be getting an interest rate I, right? I into P. But in the second year, what will happen? If here you will be getting on the interest rate I, and here again you will be getting that interest rate I, so that is equals to I into I P, right? Again in the third year, what happens? You will be getting here on the interest rate, this is I. On this also, on this interest also, you will be getting that interest that is I into IP. And here also you will be getting I into P. Again, on this, you will be getting IP, right? So this is how the simple interest and I mean compound interest thing works. So you are getting interest on interest. So this was your interest on which you are also getting the interest, right? So every subsequent year you will be getting interest on the interest. So this is the benefit of the compound interest. So most of the time, if you'll see if a particular amount is getting invested in the market, then that will be based on the compound interest. The reason is that in compound interest, you will be able to earn more amount of money or more amount will be there in case of compound interest compared to the simple interest. So if I want to calculate the amount after an year or compound interest that is equals to P into 1 plus R whole to the power n. Right? This is the formula of the compound interest, right? P into 1 plus R whole to the power n. Now, so sometimes what happens, I mean, if compounding is annual, it's fine. But if compounding is not annual, in that condition, what you will see? So the thing will be different. So here, in this case, if compounding annual, then you can use this particular formula. But if compound is not annual, then in that condition, you will have to go by some different method. Right? What is the meaning of this thing? Let's say in every year, in let's say 0 to 1 year. So here compounding is only one year. You will be getting an interest rate on the basis of annual. But sometimes you will be given that okay, compounding is based on monthly, yearly, I mean monthly basis or weekly basis or daily basis or hourly basis. So in that condition, the value of compound interest that you are getting annually is not same like you will be getting on the basis of daily compounding or monthly compounding or weekly compounding. So if compounding is not annually, If compounding is not annual, then the compound interest formula can be written as P into, or S can be written as P into 1 plus R upon M whole to the power Mn. So let's say I'll be talking about this one is your future value, S. S is your future value, right? Here, this S is your future value of the assets, and your P is your present value. On this particular present value after n year, how much future value will be there for this particular asset P? That is your S. So S is your future value and P is your present value. So where R is your, here in this formula, R is called as your nominal interest rate and M is your number of compounding or intervals per year, right? I'll tell you later what is the value of N. N is called as number of years of compounding, right? So this is how this future value and present value can be related in case of your compounding is not annual basis, right? So that is not annual. So I'll be talking about two kind of interest rate. So two kind of interest rate will get arise while talking about the compounding. First one is your nominal interest rate, and second one is your effective interest rate. This concept is very important. So first I'll be talking about nominal interest rate. So in case of nominal interest rate, usually the length of interest period N is 1 year, and the interest rate is, let's say, I, is based on the year, right? So even when the actual interest period is not 1 year, the interest rate is expressed on the annual basis, right? So here, in case of nominal interest rate, the length of interest period N is 1 year. So annual basis, you will be taking the interest, and based on that, you will be doing the calculation, right? So let's say if I'm talking about option A, let's say 3% compound annually, compounded annually. What does it mean? The value of R is your 3% and the value of M is your 1. Why? Because this is compounded annually.